Definition of machine design. Machine design is defined as use of scientific principles, technical information, and imagination in the description of machine or mechanical system to perform specific function with maximum economy and efficiency. Okay, so in this particular subject, the prerequisite is the different prerequisites are what? Your strength of material subject, then material science, then theory of machine. Okay, so all that basic principle you have to use over here. You require to select the material for that particular component, and you have to, considering all that factors, design the one particular component that fulfill the requirement of customer with a good quality, and by optimizing its cost also. Okay, so it maximize your economy and efficiency. Okay, so machine design is like this. General design procedure. Now these are the steps in general design procedure. Recognition need. First of all, you have to identify the need for any particular thing. Okay, then definition of problem. You have to formulate the problem statement regarding completion of the customer requirement. That is nothing but definition of problem. Then synthesis, analysis and optimization, then evaluation and the presentation. See, um, design is nothing but to design. Many of the student having in their mind that design means modeling. Okay, if you able to form the 3D model, then that is called as design. It's not like this. Design means what? First of all, you have to identify the need of customer. You have to formulate the problem, okay, related to that need, and by doing synthesis, analysis and optimization, then evaluation, and after that you will obtain the dimensions related to that machine element, and in actual working condition you have to check whether that particular component will get fail or not. That total procedure is called as what? Design. And after that, whatever the dimension that you obtain, from that you will form the 3D model. Okay, so 3D model creation is not the design. Okay, actually, first of all you have to obtain the dimension regarding that component, and then from that you have to formulate the 3D model. Okay, so all that procedure, okay, combinedly called as design procedure. Now in this particular subject we only focus on machine elements, small machine elements. So basic procedure of design of machine element. So this procedure we follow for every particular component. Specify the function of element. Now function of element means what? The design of machine element begin with specification of function of element. So let's say bearing. What is the function of bearing? To support the
To
rotating
support.
shaft. Yes, to support the rotating shaft. Okay. Then what is the function of key? What is the function of key? To transmit the torque between shaft and whatever the adjoining machine part connected to that shaft, like gear, pulley, and sprocket. So what is the function of key? To transfer the torque from the shaft to the gear, that gear mounted on shaft by means of key. Okay, so what is the function of key? To transmit the torque from shaft to say adjoining machine part like gear, pulley, and socket. Okay, then spring in clock. What is the function of it? To store the energy and release it. Okay, so this is spring in clock. It's one machine element. Then power screw to produce uniform and slow motion to transmit the force, right? So you have to identify the function of particular element first of all. So this is the first step in that particular design of machine element. Then determine the forces acting on the element. What are the different forces acting on that element during actual working condition? You have to focus on that. So what are the different forces may be present? First and very important is what? It's dead weight. Okay, that machine element having dead weight, and you can call it a static force. Then if it having some particular motion into that, then force due to frictional resistance that may be present over there. Then you can say centrifugal force due to change in direction of velocity. Okay, then inertia force due to change in linear or angular velocity. Okay, then you can say force set up during manufacturing the part resulting in residual stresses. Okay, then the external force due to energy or torque transmitted by machine part. Okay, so you can call it a useful load again. Okay, so these different forces acting on that element, you have to identify that forces first of all. Okay, then third step is what? Select suitable material for element. Now you must have a very good knowledge related to the material. Okay, see, material selection is very much important step in design procedure. Okay, so you must have a very good knowledge about the properties of material, and you must know the different types of materials. Okay, for example, we are taking the flywheel and housing of gearbox. Gearbox housing is so much complicated. Okay, so which material you prefer for that? Which material property is like to uh, acquire the complicated shape during manufacturing? See, flywheel and gearbox housing or engine blocks, okay, that are having complex shapes. These components are made of cast iron. See, what is, yes, correct, cast iron. And what is the property of cast iron? The cast iron, because the casting process produce complicated shape without involving machining operation. Okay, so what flywheel, then gearbox, those components having very complicated shape. Okay, you have to produce it with cast iron. Then yes, transmission shaft are made of shafts are made of transmission shafts. Shafts कुठलं मटेरियल असतं जनरली? Transmission shafts are made of plain carbon steel. Okay, because they are available in the forms of rods. Okay, cylindrical shape. So likewise, you have to identify for particular machine element which material you prefer. So for that purpose, you must have a very good knowledge about the material and their properties. So this is what: select suitable material for the element. Then determine the failure mode of element. Okay, failure mode. What are the different failure mode? During actual working application, because of the different forces, acting on that element, what are the different failure criteria that you have to identify? Okay, like the failure may be because of elastic deformation, failure may be because of general yielding, failure may be because of shear stress, failure may be because of bending stress. Okay, so you have to identify the criteria of failure. Now let's be focused on failure of key. All of you know that key is present in between shaft and, let's say, gear. The function of key is to transfer the power or torque from shaft to gear. Okay, now which type of failure present inside the key? All of you know that half power for general key structure, half part of the key is present inside the shaft and half part of the key is present inside the gear. Okay. And for example, for a moment, let's say shaft is stationary in the assembly of what? Shaft, key, and gear. In that assembly, for example, shaft does not move. Shaft is stationary and gear is moving. Okay. So in that case, how the key will get filled? As half part of the key is present inside the shaft and half part of the key is present inside the gear. So in that situation, what happened? Shear failure get occur exactly at the center of your key. Is it? Correct. So likewise, you have to identify the failure criteria in every particular element. Okay. Now let's say we are focusing on the design of shaft only. Now shaft is used to transfer the power. Okay. Let's say we require to transfer the power from one particular distance to another distance. So what are the failure criteria inside the shaft? Because of the torsion, because of the twisting, okay, shaft may get failed. So this is one failure criteria. So likewise, there are different failure criteria. You have to identify it according to the function of that element inside the system, okay, and accordingly you have to design the SEP element so that element will not get failed during actual working condition. Then determination of geometric dimensions of element. So depending upon the failure mode, after cross checking it, okay, you have to find out the dimensions. Let's say for a bearing, outside diameter, inside diameter. Okay, bearing is standard element, so you may select it from the standard charts. Now let's say for design of keys, what is the length of key, what is the height of key, what is the width of key, that you have to determine depending upon failure mode. Okay, once we identify the failure mode, you will design it like that it will not get fail in actual working condition, and according to that we have to find out the dimensions. Okay, then modify the dimensions for assembly and manufacturing point of view, and once again check the design in critical cross section. So once you find out the dimension for a particular element, again you have to confirm that whether such a type of element with that dimension is possible to manufacture or not. So you have to confirm that thing. And if it is required to modify some particular dimension in order to manufacture it, okay, you have to do that thing at this step. Okay, but be confirmed that it will not get fail in actual working condition. Okay, then prepare working drawing of element. Okay, that means assembly and detail. Okay, so this is total procedure of design of machine element. Okay, is it clear to all of you?
Yes, sir.
Now, basic requirement of machine element. Strength. A machine part should not fail under the effect of forces that act on it. It should have sufficient strength to avoid failure either due to fracture or due to general yielding. Okay, so this is important point. Strength. Rigidity. A machine component should be rigid, that it should not deflect or bend too much due to forces or component that act on it. So all that requirements you have to focus in during actual working condition. Then manufacturability is the ease of fabrication and assembly. The shape and material of the machine part should be selected in such a way that it can be produced with minimum labor cost. See, cost and quality, all the mechanical industry depend upon these two factors. cost and quality. See, when the quality is more, cost is also high. Every time the customer, you have to design the machine or any particular system according to need of customer. See, sometimes the customer may not require that much of the quality, so you may produce some less cost, less quality material or a system that fulfill the requirement of customer. Why? Because customer require low cost. Okay, see, Chinese product. This is the best example of Chinese product. You say some Chinese product having very good quality, but its cost is high. But some that are very low quality and cost is low. So they manufacture according to the need of customer. Okay, so quality and cost is very much important in mechanical field. Okay, so you have to focus on this also.